Welcome to Excel 2013 Statistical Analysis video number 27. Hey, if you want to download this Excel workbook or the PDF files, click on the link below the video. Hey, we're in Chapter 4. We're talking about probability. And in this video, we're going to talk about adding probabilities. Now, we're going to start with defining a Venn diagram. Hey, these are diagrams that show the relationships between different events and the sample space. So let's check out the complement rule. Here's our data set. And we're going to use this data set here in the PDFs and then over in Excel. Simple data set to help us understand our adding rules for probability. Hey, we have hair color and eye color. And you could see Sue has brown hair color, hazel eye color. Chin has black hair and blue eye color, and so on. Now let's look at the complement rule. Here's the probability of having brown hair. And all it is counting brown 4 times and dividing by the count of 10. Well, here's the whole sample space. So the complement rule says if we take 1 minus the probability for the event, we get the probability for everything else, which is the complement. In our case, that would mean black and blonde, because those are the only 2 other possibilities. Complement rule, and we'll use that a lot. Now, we need to talk about the concept of mutually exclusive. Think of it as dating only one person. If you ask the question, how many sample points have brown hair and black hair? Now, we're excluding the fact that people can dye their hair different colors. You're only allowed to pick one in this data set. Well, there's no overlap whatsoever. You can never find in this single hair color column both brown and black. That means they're mutually exclusive. In terms of adding, it's going to be simple. What's the probability of having brown hair or black hair? You just add them. Now, that's mutually exclusive. We want to talk about union and intersection. The union, you can think of it as or. We're asking the question here, a much different question. We're going to define the event brown hair or hazel eyes. If we look up in the data set, we can see brown hazel, brown hazel, brown brown. That means hair color, eye color, and then brown hazel. So there's some of each. And if we were simply to add the probability for brown and add it to hazel, we double count. Now, a union means all the sample points for brown or H or both. Now, this is the union. It's everything, but notice there's some overlap. When we get to our adding rule, we're actually going to add brown plus hazel and subtract the overlap. Why do we have to subtract? Because we don't want any double counting. Now, that little bit right there is called intersection. Another way to think of this is and. Who has brown hair and hazel eyes? And there's a bunch of words for both union and intersection. If we look at union, we can use the word union, brown or H or both. We could say or criteria, which is what I tend to do in some of my other classes. Here, we use the word or, but the textbook tends to use this symbol. This means union. Now, you can remember that it's union because it looks like a U, right? I use or. The textbook uses union, but no problem. Most of my diagrams, I'll list both. Also, you'll see at least one, because remember when we're talking brown hair or hazel eyes, someone might have just brown hair, or they might have just hazel, or they might have both. So the union, sometimes they refer to it as at least one or more. Now, intersection, this is the and situation. There's a bunch of words for those. Intersection. We could also say brown and H. We could also say and criteria, which is what I tend to do in some of the other classes, non-statistical classes, straight data analysis. It's an and logical construction, just like up here. This is an or logical construction. But it's the same. Here in statistics, it's exactly the same. We just have some different words. But check this out. They also say both when there's 2. They say joint. They say concurrent. And also, you can think of it as getting 2 trues. So union, that's or. Intersection, that's and. Now we'll get to our adding rules in just a second, but there's a connection between union and intersection, because if you're asking the question, what's the probability of getting brown hair or hazel eyes? Yes, we're going to have to add, but we're also going to have to subtract that little bit, which is our intersection, which happens to be an and or intersection situation. Now let's scroll down here. Here's addition law for probability. When the events are mutually exclusive, like brown hair and black hair, think of it visually like this. There's no overlap, so it's perfectly all right to just go ahead and add. Here's how I will refer to it: probability of brown hair or black hair. The textbook says probability of brown union. That's the symbol for union, or symbol for or, black hair. We simply add to get 0.7. If the events are not mutually exclusive, think of it visually like this. Oh, there's some brown hair. There's some hazel eyes. But that little intersecting bit will get us into trouble if we just add the two. We have to subtract it so we don't double count. I'm going to refer to it as probability of brown hair or hazel eyes. The textbook will refer to it as probability of brown hair union hazel eyes. We simply add the two, and don't forget to subtract the and, the little bit in the middle, so we don't double count. So in this case, we would go ahead and get 0.4 plus 0.3 minus 0.3. Now, how do we calculate these? We'll do these over in Excel, but we started with this small data set just so we can see. Well, what's the probability of brown? 1, 2, 3, 4. So 40% because we're dividing by 10. What's the probability of hazel? 1, 2, 3. 3 divided by 10 is 0.3. But what's the probability of and, or the intersection? Oh, brown, hazel, that's 1. Brown, hazel, that's 2. Brown, 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 hazel, that's 3. So for and, it's 3 divided by 10. That's how we got these numbers. Probability of brown hair, 0.4. Probability of hazel eyes, 0.3. And probability of brown hair and hazel eyes, 0.3. So when we do that math, we get 0.4. Now, here's our summary, right? Picture like this, just add them. Picture like this, there's some overlap. Please don't double count. We're going to have to add the two and subtract the and. Now let's go over to Excel and check this out. Here's our adding law. We're subtracting the and. By the way, if you just remember this one, right, and you get to the situation where you're trying to find the and there are none because they're mutually exclusive, that'll just be 0. But if the events are mutually exclusive, we just add because there is no and. All right, let's look at our example here. Example 1, adding laws for probability. We have to talk about and or, and complement. Now, we're going to start off talking about Excel counting for and, Excel counting for or criteria when the events are mutually exclusive, and Excel counting when there's or criteria and there's a subtraction for the and. All right, let's go ahead and remind ourselves, because we've already done this. If we're counting hair brown, eye color hazel, that's 2 true. So what do we use? Equals COUNTIFS. So criteria range, there's all the hair color. Comma, criteria, I want brown. Comma. As soon as I go from criteria range 1 to criteria range 2, I'm doing and criteria. I'm going to highlight eye color, the whole column for criteria range 2, comma, and now I give it the criteria. That's going to find 2 trues for each brown and hazel. And when I Control Enter, it counts 3. Now the probability is easy enough. Equals 3 divided by the total count. COUNTIFS for and when you have 2 conditions, or in fact 2 or more conditions. So enter and we get 0.3. Now let's talk about or when there is no overlap. That means they're mutually exclusive. And here's a rule of thumb for Excel. When your or criteria are coming from the same column, it's just going to be a straight COUNTIFS plus COUNTIFS, meaning I need to count all the browns, then count all the blondes. It's just a straight counting. But when we get down here, notice hair color and eye color, there's 2 columns. So as soon as you start doing or criteria from 2 columns, you gotta think carefully. You're gonna have to deal with and. That means overlap. That means double counting. All right, so mutually exclusive. Here in the cell for count, I'm simply going to use COUNTIFs. Now, we're using COUNTIFs for everything. 1 condition, 2 conditions, 1 criteria, 2 criteria, or more. So the key is I'm only going to enter criteria range 1 into this for hair color, comma, then the criteria, right? Then I close. It was only a 1 there, so I know not doing and. I'm just doing a single condition. Now I'm simply going to add and COUNTIFs. Add. And this is the same column again, but here we have comma, a different criteria. Because there's no overlap, we can simply add the 2. Close parentheses, Control-Enter, 7. Now the probability for this mutually exclusive or is 7 divided by the total count, and Enter. Now we got 0.7 for this or event, brown or blonde hair. Now this was a mutually exclusive event. Down here we want to look at an event that's not mutually exclusive. Brown hair or hazel count. Now if we look up at the data set and we start looking at the 10 records and asking this or question, brown or hazel, let's just go through the data set. Brown or hazel, true, we got a count of 1. Brown or hazel, neither one of them are, so we don't count that one. Brown or hazel, don't count that one. Brown or hazel, this is true, so our count so far is 1, 2 records. Brown or hazel, false. Brown or hazel, false. Brown or hazel, yes, we got at least 1, so we count. This is the 3rd record. Brown or hazel, that's the 4th record. Brown or hazel, false, false. We get a total of 4. Now notice down here in our formula, we're going to have to follow our rule. Probability of event brown hair plus probability of event hazel eyes, and then subtract the and. That means brown and hazel. For example, that one. Let's just eye this. 1, 2, 3, 4. That's the count for event brown. We're going to add to it the count for event hazel. 1, 2, 3. That's 7 total. But wait a second. 1, 2, 3, 4. We got a count of 4. Oh, but if we subtract the and, the records with brown and hazel, that's 1, 2, 3. 7 minus 3 will give us 1, 2, 3, 4. All right, so just like the probability formulas from our textbooks, but now we're going to use COUNTIFs. We're going to count for the event brown hair, highlight all of them, comma, and brown. Now notice we're using COUNTIFs, but it's only got 1 criteria 1 and criteria 1 range. So we know it's adding for a single event, close parentheses, plus, and then COUNTIFs. This event is hazel eyes. That's the whole range, comma, criteria 1 is hazel. Notice we didn't get to criteria range 2, so this is still a single condition. That's the count for hazel. And I can see I mistyped there. That's a plus. 4 plus 3. And now we need to subtract the and. COUNTIFs. Now we're going to use COUNTIFs again, but because we enter 2 conditions, there's the first criteria range, comma, criteria 1. Boop. And as soon as we jump over to criteria range 2, we know we're doing and. So this will subtract for all of the hair colors, and then the criteria hazel. So there we go. That will count the and when we enter this, we'll have 4 plus 3 minus 3. Boom, 4. That is our count for the event brown hair color or hazel eye color. Now the probability is straightforward, equals, hey, that 4 divided by the count, And boom, our probability is 0.4. Now, the wrong formula, I should have done that over here. This is a common mistake. People will simply add. But if we simply add the two events, we get way double counting. That is a 7. Now, this event was mutually exclusive, and we got a hint because it was coming from a single column, right? So we just COUNTIFS with one condition or criteria each. This event right here, we can see the overlap. It's coming from 1, 2 columns. So we had to COUNTIFS plus COUNTIFS for the two individual events, and then subtract the and. Now, our next example, we want to talk about the complement rule. And we can see over here, here's our Venn diagram. That's the probability of brown hair, 0.4. That's our entire sample space. If we want everything not brown, 1 minus the probability of brown hair, and we get 0.6. Now, let's come over here and calculate probability for brown hair. Well, let's count first. We've already done this a few times. Criteria range, all of the hair color, comma, and the criteria. Close parentheses. That gives me the count. That's not what I want, so I have to divide by the total. This is calculating the event brown, tab. There's our probability. Now to calculate not brown, everything is always going to be 1 minus whatever the event is, and this will give us everything that's not brown, which in our case happens to be just black and blonde. But there you go, 0.6. Now let's scroll down and look at our next example. Example 2, adding from a frequency distribution. Oh, we already did this. Here's eye color, so we got a unique list from this column. Boop! COUNTIFS or pivot tables. We counted, got the frequency, adds up to the total number of records in this data set. We calculate equals the frequency divided by the total. We got our probabilities for each one of the individual events. Notice each one is between 1 and 0 inclusive. Added up to 1 or 100%, so both of our requirements for probability are true. Same thing for hair color. Now, if we ask the question, or, and this is hair color, brown or blonde, there's no overlap. So we simply can take from our frequency distribution for hair color, hey, brown, boom, 40%. Plus, we have blonde, 30%, and enter. So lots of times we'll be given frequency distributions or cross-tabulated tables, which we'll look at later, with percentages. Our next example, here's our cross-tabulated table. Here's the data set. And then I went ahead, and actually, this is done with formulas, but I colored it exactly like the textbook. Almost all the homework problems, when they're giving you cross-tabulated tables, they show it like this. We know from earlier study in this class, we can do this with formulas or a pivot table. We'll see later 2 videos ahead how to create this with a pivot table. We've already done it. But notice we have eye color and hair color. The intersection is always going to be our and. Now, we want to look at this table because the textbook uses certain terminology. The inside part, and here's our hazel and brown. That's an and percentage. I always say and because there's 2 conditions that are met, 2 truths. That's the inside of our crosstab. The textbook always calls it joint. It could be and. It could be intersection. So all of the percentages on the inside, that means brown and blonde is 10%. Those are and or joint. The outside edges of our crosstab tables done with percentage are going to be called our marginal probabilities. Now notice that in Chapter 2, we did cross-tabulated tables. This would have been percents of grand total. That means all of the ands on the inside and the marginals along the edge in the margin, right, are all divided by grand total. And we'll see how to do that later, or we'll remind ourselves how to do that 2 videos ahead. Now, this whole thing is going to be called a joint probability table. That's what they call it in the textbook. Now, let's scroll over. Because we want to practice calculating and, or with mutually exclusive, and or with not mutually exclusive events, we want to practice calculating these probabilities from a cross-tab table. Now, if we ask the question, what's the probability of getting brown hair and hazel eyes? That's just the inside of the table. So we simply, if we're given our percentages in this form, we simply take whatever's on the inside. Notice brown is the column header and hazel eyes is the row header. So the intersecting percentage, that is whatever the count is divided by the grand total. That's our probability. Now if we're given probability of brown or blonde, that means if they're mutually exclusive, they're going to be categories either along the column headers or row headers. This is hair, so we got equals brown, or we add blonde. These are mutually exclusive, so we can simply add. Enter, and there's our 0.7. Now, when we do OR criteria and we have overlap, right, hair color brown or eye color hazel, we're going to have to be a little bit careful. But hey, wait a second. We can figure this out. There's all of the hazel. Remember, the margins are a single condition probability based on whatever the count was by the grand total. So we simply add hazel, add the brown hair color, and subtract the and. So when you're given this, it's going to be much easier than having to do it from raw data. So equals, we're going to go brown hair plus, we're going to go hazel eyes, and subtract the and. Brown hair and hazel eyes. And enter. There we go. So when we're given it in this form, as long as you remember marginals, and you can calculate a bunch of different probabilities. Now let's go look at our next example. Flight arrival information. So our favorite airline, we have this collected data early. Well, that was 100 times. On time, that was 800 times. Late, 75, and canceled, 25. Hey, this is just a frequency distribution. Add them all up. That equals the number of records. Calculated the probability. Sum of 1. Each one is between 0 and 1 inclusive. We can just go ahead and calculate straight probabilities. Hey, these are all mutually exclusive categories. Remember, if we have a frequency distribution, the categories have to be mutually exclusive and collectively exhaustive, which means there's enough categories to count everything from the original source data. So calculate probability that a flight is early or on time, we simply add early plus on time. And that makes us happy because 90% of the time, we're going to get just what we want, early or on time. Now, not canceled, we really want to fly to our location. So we're hoping it's not canceled, and we want to calculate the probability. Oh, there's canceled. We'll use our complement rule, equals 1 minus canceled. And that gives us not canceled, 97.5%. All right, so we can calculate straight from a frequency distribution with mutually exclusive categories. Let's look at our last example, travel survey of people who visit Seattle. Now, most of the time in this class, we've done calculation based on the entire data set. But a lot of this chapter, and oftentimes probability, you're just given the probability. Somebody already did the heavy lifting and calculated the probabilities for us. So here's our situation. They did a survey, and they found that for the event visit Space Needle, we had 0.45%. For the event visit Pikes Place Market, we had 0.65%. And for the event visited both, 0.25. So if we ask the question, hey, what's the probability of Space Needle or Pikes Place Market? Hey, we have some overlap and both, right? So we go probability of Space Needle plus probability of Pikes Place and subtract the and. So in this case, this is the easiest of them all. We simply take Space Needle probability plus Pikes Place and subtract the difference. Boom. Now, in the problem, sometimes they'll say things like visit at least one. So don't get tripped up by that. All right, so in this video, we talked a lot about adding. We saw how sometimes they'll just flat out give us the percentages, and we have to calculate either mutually exclusive or, in our case, not mutually exclusive OR calculations. Then we saw that we can calculate straight from a frequency distribution. And if it's a frequency distribution, the categories are going to be mutually exclusive. And if we're given a cross tab, we can calculate The marginals, which will be our single conditional mutually exclusive events for either the column headers or row headers. The intersection is the and. We also saw here a frequency distribution. Hey, we can do or mutually exclusive, just add them. And we also saw sometimes when you have raw data and you're using formulas, how to use COUNTIFS for and, which we already knew in this class. COUNTIFS for or if the categories are mutually exclusive. And don't forget, if they're not mutually exclusive, just add that extra little one that subtracts the and. All right, next video, we're going to talk not about adding, but multiplying. We'll see you next video.